30 seconds.
Frank, can we hold a minute?
Hey, tell them we need 1 minute.
Hold 1 minute.
1 minute.
Live TV, folks. We won't hold too much longer, otherwise I regret that you not need to warm it back.
So tell them about it.
Frank? Don't worry. Give 30 seconds now. She's gonna give me 30 seconds.
Okay. Tell them they're gonna, I'll give them 30 seconds.
You said she'll give us a 30 seconds.
30 seconds.
30 seconds. 30 seconds.
We'll go right on 31. Fifteen seconds. 10, 9.
I guarantee you that at some point, everything's going to go south on you.
Really?
You're going to say, this is it. This is how I end.
Yeah, Martin's dead. We have to go again.
Now, you can either accept that, or you can get to work. This will come as quite a shock to my crewmates, and to NASA, and to the entire world. But I'm still alive. Surprise. Here's the rub. It's going to be 4 years for another mission to reach me. And I'm going to have designed to last 31 days. So I got to make water and grow food on a planet where nothing grows. But if I can't figure out a way to make contact with NASA, then none of this matters anyway.
We've got an incoming message.
My God. Mom Wolfie is still alive. In your face, Neil Armstrong. Okay, so let's do the math. I have enough food to last for 50 days. He's going to starve to death long before we can help him. So I'm going to have to science the out of this. He's 50 million miles away from home. He's totally alone. What the hell is he thinking right now? I am the greatest botanist on this planet. I know I saved my body.
But we need to hurt his crew.
We either have a high chance of killing one or a low chance of killing six. We're not risking their lives. It's bigger than one person.
No. It's not.
NASA rejected the mission.
So if we do this,
We're talking agreement. Anything goes wrong, we'll die.
do you realize how crazy this is? We got no other option.
No matter what happens, tell the world, tell my family, I never stop fighting to make it home.
Good stuff, huh? I'm Cabana. I'm the director here at NASA's Kennedy Space Center, and I have the privilege of leading this amazing team that is helping take us on a journey to Mars, a real journey to Mars, and it's going to be awesome. Well, I got a few folks I want to introduce in the audience before we get started, and I expect to hear some loud applause as certain folks are introduced, and I think you'll figure it out. From Cocoa, Florida, we have the Bionic Tigers. And these are first robotic teams that are in the area. From Cocoa Beach and Rockledge, Team Pink. see here, I see some empty seats. From astronaut in Titusville High School in Titusville, Combat. All right. And we got a CubeSat team from Merritt Island building StangSat. In addition to that, we've got over 10,000 students from across the United States on NASA's largest distance learning network event we've ever done. NASA's on a journey to Mars. Already, from these shores out here, robotic precursors have launched to the red planet, and they're roaming it right now, learning and exploring. But right here at Kennedy Space Center, from launch pad 39B, right out here, we are preparing to launch humans to Mars. Over in the Vehicle Assembly Building, right behind us, High Bay 3 has been totally gutted of all the shuttle infrastructure, and we're putting in the new platforms to support a rocket that's going to be more capable than the Saturn V, NASA's Space Launch System. And on top of that is going to be the Orion vehicle, the Orion crew vehicle, multi-purpose crew vehicle that's being built right here at KSC in the Operations and Checkout Building. That is all happening right now. We are preparing to send humans beyond our home planet once again, and it is absolutely awesome. All right? In addition to that, we're enabling commercial operations to low Earth orbit. We're building the capability to get crews to the International Space Station on a U.S. rocket. There are just all kinds of great things going on. Well, I had the privilege of flying on the Space Shuttle 4 times, and let me tell you, that is one heck of a ride. And what I wouldn't give to do it again, what I really wouldn't give is to be able to ride that Space Launch System on a journey beyond our home planet. But, you know, that's going to be up to you guys, okay? And I'm looking forward to seeing who ends up on that first trip to Mars, because it's going to be something special. Now, I often get asked, how do you become an astronaut? Well, obviously, you got to meet all the technical qualifications, right? Well, I think that one of the primary goals is persistence. It's not giving up. And finding your passion. I challenge all of you, find your passion, because a couple things happen. First off, if you're passionate about it, you're going to do really well at it. And we look for folks that excel in their field. Not only that, it's going to make it fun, all right? And work isn't work, it's fun. And that's what's cool about being here at KSC. I don't care what you're doing at Kennedy Space Center. Folks are passionate about it. They enjoy their work. I just love coming to work every day, being part of this team that is making science fiction science fact. It is awesome. I wanted to be a pilot. Flying was my passion. And I got down to Pensacola and I didn't pass my eye test. Oh man, was I disappointed. And I became a naval flight officer for 3 years. And I finally, convinced them I could see. They caught me on a technicality, but I passed all my eye tests after that. I got back down to Pensacola, and I became a naval aviator. I was a Marine pilot, but a naval aviator, got to fly. And then I said, man, I'd like to use all that math and engineering I had in college, Naval Academy, along with my flying abilities and be a test pilot. So I applied for Navy Test Pilot School. And said, sorry, Bob, we don't need any A6 pilots. 6 months later, I got picked up for Test Pilot School. Well, then NASA's taking applications for the shuttle program, and I applied for the 3rd group of shuttle astronauts. I actually qualified. And I went through the whole process, and I just couldn't wait for that call that said, come on down. And the call came, and they said, sorry, Bob, you didn't make it. Oh, man, was I crushed. But they said, we're going to take some more next year. We'd like you to try again. So I went through that whole process again, reapplied, and was fortunate enough to get selected the next year. So I didn't get into pilot training on the first try, didn't get into test pilot school on the first try, and I didn't get into the astronaut program on the first try. Persistence, okay? Set a goal for yourself and don't give up and follow your passion. And I'm telling you, dreams can come true. They sure did for me, and they can do it for you too. All right, so right now, I'd like to introduce NASA's real Martian, the head of planetary science at NASA headquarters, Dr. Jim Greene. Jim?
Indeed, before you really watch the movie and get absorbed in that, I need to give you a little background about Mars. So if you have my first slide, what we'd like to do, of course, is to learn to be a Martian. And I don't see my slides yet. So let me mention a few things while they're getting them up. And that is indeed, Bob is right. It really takes persistence. I have my own story in that, and so please really listen to that and take his advice. Well, let's talk about Mars in its past. Mars looked much more like Earth 3 billion years ago. We know that now. We have a rover down on the ground that's made measurements of ancient river and stream beds, and in fact, the northern hemisphere of Mars, 2/3 of its northern hemisphere was underwater. This actually is a pretty good representation of what Mars probably looked like 3 billion years ago. It's at that time, 3 billion years ago, that life started here on Earth. And so perhaps life started on Mars. And one of the things that we've been trying to do is follow the water. Where is the water? Where did it go? Next slide, please. And indeed, to be able to do that kind of work, we needed a rover. And our rovers have landed, and we've toured through several areas that we're going to talk about. But first, here is a view of from the Mars Reconnaissance Orbiter of evidence of flowing water. And what happens, next slide please, hopefully this is an animated slide. No? Okay, that didn't work either. Next slide please. We're going to keep going. What we found on Mars is craters that literally weep. And we now know that's made of water. That is briny water actually, and because the temperatures are so low on Mars, that water has been able to stay in that form before it evaporates away. Now here's an overview of Mars. Here's where we've actually put things down on the ground. The Vikings, Pathfinder, which Pathfinder actually plays a prominent role in the movie The Martian. Phoenix, we landed several years ago, and Spirit and Opportunity, you can see where they are. But the two rovers that are working today are Opportunity and Curiosity. And in fact, the next one that we're going to launch right out here, actually it's in Vandenberg, I forgot. So we're going to go to Vandenberg next time and launch the InSight mission in March. And this is where it's going to land, just above Curiosity. So next slide, please. So here's Curiosity. This actually is a selfie. It's made up of 54 individual pictures that they sent back, and indeed we knitted it together to show you what it looks like on the beautiful Mars planet at a place called Gale Crater. Next slide, please. So what did Curiosity find? Curiosity has a drill. It's gone down below that red soil, what we call perchlorates that we talk about a lot that's on the soil. And when you see these holes and the amount of material that's come up, it's gray Mars. It's a completely different type of soils. It's got carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it's far more moist than we ever imagined. And so a lot of the water that was on Mars actually has gone underground. Next slide, please. So here's our current array of satellites. We have our orbiters, also our two rovers that are working. As I mentioned, the next one we're going to launch is InSight in 2016. And then ESA is going to launch a mission called Trace Gas Orbiter. And that will arrive also on the red planet late in 2016, about the September, October timeframe. In the future, ESA is developing a rover called ExoMars, and we're building right now the Mars 2020 rover. And this will launch in 2020, and of course it takes about 9 months to get there. And it has an array of wonderful instruments, as briefly shown on the next slide. So here's all the instruments. It sort of looks like Curiosity, but it has a whole new set of instruments. And there's one from Norway. This is a ground-penetrating radar. We're going to be looking for aquifers. We're going to be looking for where perhaps water is stored underneath the surface of the planet. Next slide, please. One of the really neat experiments is called MOXIE. And this instrument, this Mars Oxygen In Situ Resource Utilization Experiment, so it's an acronym within an acronym, we love doing that. That's called MOXIE. This brings in the CO2 atmosphere, and through a process we call electrolysis, pops off an oxygen, vents the carbon monoxide, and then stores the oxygen. It does it in the morning, it does it at noon, it does it in the afternoon, it does it at night. It does it through the whole day and throughout, off and on through the whole year. This provides us a baseline for us to be able to understand when the most efficient times are to be able to extract oxygen out of the very thin air of Mars that we can use for a whole variety of things. Fabulous instrument. Next slide, please. We're also developing a variety of technologies that we're going to plan on using next. One, of course, is the deep space optical communication. We use radio waves to communicate back and forth with our satellites. And the way we can get more data is to change the wavelength. Instead of a very long wave, a radio wave, we're going to use the very short wavelengths of light. We can transfer far more information. So we're going to have optical communication from Mars to Earth. We'll need it because we'll need the video, we'll need the audio, and we'll need the data. And it's only that mechanism that will allow us to bring all that back in a very timely manner. We also are developing solar electric propulsion. This is where we take a gas, it's typically xenon, we ionize it, that means we pop off some electrons, and then we accelerate it out the back of a spacecraft, and that pushes us in the other direction. So it is like the, on Star Trek, it would be like, not warp speed, but what did they call it? Impulse speed. It's just that low little trickle that we need. This is the first start of it. And these are going to be huge ion engines that will allow us to haul tens of tons of material back and forth to Mars. We're also developing the capability to put large mass down on the ground. Right now, Curiosity is a 1 metric ton rover. But to support humans, we're probably going to need an area that will support 40 tons worth of habitats and other things that we'll need to put on the ground. And our thinking is we'll probably do it in sections, 10 tons each. We'd like to be able to do more, but if we can go an order of magnitude better, that would be spectacular. So the entry, descent, and landing capability that we're developing now is hopefully going to give us that order of magnitude advance. And that, of course, are key technologies that really help make the humans to Mars happen. Next slide, please. So how do we get there? It takes exploration. It takes our human exploration to do a variety of things. It takes our science to lead the way, and it takes technologies to help us make it happen. And next slide, please. How we do that is the exploration activities are currently going on Space Station, low Earth orbit, pioneering a number of the things from growing food. You know, we've grown food now in space, romaine lettuce, and doing other kinds of research in that. Long-term access to space, you know, living in space for long periods of time. One of the Kelly brothers is doing that now. And of course, the next slide please, we're developing the capability with the Space Launch System and the Orion capsule to go well beyond Earth orbit, well past Moon, and into deep space. And next slide please. And of course, we're developing the science tools now, the continually orbiting and roving on Mars to be able to get us the information to know what Mars is really like. So it's the combination of these three activities that will make it happen. And so, next slide. The evolution of a Martian starts with our science. It starts with our ground truth that we get from our rovers, and it builds up to human exploration. And so with that, I think I want to introduce the next segment, which is a video. This will tell you much more about exploration on going to our journey on Mars. So let's cue that up. Thank you very much.
NASA is preparing to send astronauts beyond Earth orbit. And this time, the mission is the most ambitious we have ever undertaken. The journey to Mars. Carrying out this journey will require bringing together the best of our efforts, from robotic probes, to technology development, to astronauts in orbit, to robust new space vehicles. The journey is already underway, right here, right now. Astronauts aboard the International Space Station are learning more about living and working in space for long periods of time. Vital information for the challenging trip to Mars. Transportation to and from the station will be provided by our American commercial cargo and crew partners. Next, using the Orion crew vehicle and a powerful Space Launch System rocket, NASA will move into the proving ground of space, around and beyond the moon. Here, we will carry out increasingly ambitious missions to test out new systems and capabilities needed to reach Mars, like deep space habitats and advanced propulsion systems. Even as we speak, our robotic scouts are already exploring the red planet, preparing the way for astronauts to join them. Once we have matured our capabilities in the proving ground, we'll be ready for Earth independence, reaching our planetary neighbor, not just as temporary visitors, but as pioneers, expanding human presence into our solar system.
All right, thank you. You have heard from two of our excellent panelists this morning, Jim and Greene, about Cabana. So let's introduce the other three, and then we will get to some questions. My name is Sarah Ramsey, and I'd like to let our other panelists tell you a little bit about themselves. So with us we have Mackenzie Davis, Annie Caraccio, and Ray Wheeler. So Mackenzie, let's start with you if we can. Your character, Mindy Park, who I just finished the book and I thought was one of my favorite characters. Do you see her as inspiring young women to come work for NASA?
Yeah, I think that's always hopefully the goal with representation. I've had the luck of hanging out with Dr. Greene and with Nicole Stott, who was an astronaut who lived on ISS, well, I almost said ISIS, for 3 months over the past few days, and just getting to talk to them directly and have them explain things that I'm interested in to me in a way that doesn't feel prohibitive or exclusive has been such a treat. And I think that's what movies do as well, is they let you get to have a model for a person that you can get to know on an emotional level, and then the job that seems far away or that you hadn't seen represented before feels closer to you.
Great, thank you. Annie, you're working on some projects that I feel like Mark Watney might have found really useful. So why don't you tell us some about those?
Yeah, absolutely. So one of the projects that I work on is all about Mars ISRU, and here we have a module called the Atmospheric Processing Unit, and that actually takes in the Mars atmosphere and it converts out the carbon dioxide, which is 95% of the Martian atmosphere, and it uses cryocoolers to freeze it out. And then we send that off to a Sabatier reactor that creates methane and water. And so we really like methane because a lot of the ascent vehicles use liquid oxygen, liquid methane engines. And then water you can later electrolyze and get the oxygen for liquid oxygen or oxygen for crew, and then hydrogen, which can go back into a reactor. And it's a very sustainable reaction. So if I was heading to Mars, I'd like to know that there was a lander there waiting for me that had fuel ready or water ready for a crew or a return vehicle.
Great, and Ray, a very important question for you. Are potatoes really the future of Martian cuisine?
They are. Becky, as you know, I'm a botanist, and specifically a plant physiologist, and I've been working for NASA for getting close to 30 years now. And I've spent most of my career studying plant growth in controlled environment systems. And the intent of that is to really look at the potential for plants to provide life support for future space missions. Can they be used to produce food, and through photosynthesis can they generate oxygen and remove CO2. So, and as it turns out, I ended up studying potatoes in particular for a lot of my research at University of Wisconsin and then here at Kennedy Space Center. Potatoes are a good choice.
That's really good to know.
Until you run out of ketchup.
That is also an excellent point. All right, we're going to get some other questions. We have got an incredible audience all across the country. We've got almost 10,000 students watching via DLN, and we've got some awesome students here in the room. And we've got social media, so if you'd like to send us a question via Twitter, you can use hashtag AskNASA, and we'll get that right here. So let's start with some of our schools online. Let's go to one of our questions on the DLN.
That is also an excellent point. All right, we're going to other questions. We have got an incredible audience all across the country. We've got almost 10,000 students watching via DLN, and we've got some awesome students here in the room. And we've got social media, so if you'd like to send us a question via Twitter, you can use hashtag AskNASA, and we'll get that right here. So let's start with some of our schools online. Let's go to one of our questions on the DLN. All right, other questions. We have got
All right, I think we're having some technical issues with our DLN, so we're going to actually go to a question here in the room, and then we'll get our students online back on again. So we're going to go to our first question here on the front row.
Hi, this is for all of you guys. For people who have worked in the movie, scientists. Having worked in the movie, with science and technology, you guys doing actual, cool stuff. How do you feel about the government, being cut down for the funding for science and stuff? How do you feel that that will affect the American timeline to get to Mars and be able to do all the cool things you guys talked about?
Well, I'm turning to the NASA headquarters guy. But I'm going to make a comment on, as far as funding, from a human spaceflight point of view, and I'll let Dr. Wheeler or Greene discuss, science in general. From a human space point of view, the budget is pretty flat throughout the next few years, right? Quite a few years, in fact. We have laid out an architecture that is developing a capability. And one of the things that we need to go to Mars is a really big rocket, all right? So we've got a crew vehicle and a rocket now. We're putting that infrastructure in place. We've already flown a test flight on the capsule last December. It performed flawlessly. We're flying a test flight of the rocket with the capsule and no crew in 2018, okay? And then our goal is to fly it with a crew in 2021. Once we have proven that capability, then the money that was going for research and development on that capability now drifts off, right? Because we're in an operational phase, so we can take that delta and apply it to developing a habitability module. The Orion crew vehicle only supports a crew for 21 days, a crew of 4, all right? If we want to stay in space longer than that, then we have to have a habitability module. A trip to Mars right now with current propulsion technology, and that's why we need new forms of propulsion. I mean, we're talking 1.5 to 2 years. It's 6 to 8 months to get there, another 6 to 8 months on the planet till the planet's aligned for another 6 to 8 month trip home. So we would then develop a habitability module to support the crew in their travels. Well, obviously when we get there, we're working on entry, descent, and landing. We're going to need some sort of lander and a way to get off the planet. So it's very well staged out how we develop these capabilities as we progress, given the flat budget. And I'll let Jim talk about from a science point of view.
I'd be happy to. We've been tremendously lucky to get the support of the American people. We're doing this as part of our exploration and outreach. We have in America the explorer gene. We want to see what's on the other side of the hill. And it's just been delightful to be able to work in this particular area. The economy has really had a slump over the last several years. And once again, the administration and Congress have been really generous, as Bob says, to allow our budget to be at least flat and not decreasing. So we really owe it all to our support in America to be able to continue to do these things. What I hope you get out more than anything else today, and as Bob relayed very well, we're making steady progress. We have plans, and we put those plans in place. And what we're finding out at Mars with our robotic missions, both the orbiters and those on the ground rolling around, enable us to make concrete plans on where we're going to go, what we're going to do, and how we're going to use it. So all this is coming together really quite nicely, and so actually I want to thank you for all your support.
Here, here.
I think that answers All right, we're gonna go to our DLN. So let's go to a question from one of our DLN schools.
My name is James Salinas, and we're from Auburn, Texas, all the way to GMI. This is my question.
Considering Mars' atmosphere is almost a reverse of Earth's, what things to be done?
So if I can repeat that question, what I understood was Mars' atmosphere is so thin, how are we going to be able to live and work and live on Mars? Well, indeed, the atmosphere of Mars is maybe less than 1% in terms of its pressure that we have here. And so consequently, we have to have an environment in a suit, and that's how we'll work and live. I think the movie shows a suit design that's very workable. You have to have all sorts of ability to move, but you're also going to have rovers. You're also going to go to different places. Right now, our plans in terms of going to Mars is going to an area that we call an exploration zone. It's about 100 kilometers in diameter. We're going to land in one location there. We're going to live in another location there. And we're going to do science all over the place. And that's why we actually have to have larger rover vehicles to make that transit from place to place to place. So we've got it covered, and we're making good progress in that area.
And I gotta admit, Jim, I'm watching the previews here. I'm really envious of that suit. It looks really cool. I want to try that out.
Well, you know, our deputy administrator, David Newman, has really been involved in making some of those really nice, sleek, close-fitting suits that allow flexibility, and that's kind of some of the research that needs to be continued and perfected.
And just to put that in perspective, when astronauts do a spacewalk on the International Space Station, you know, that suit, it's a vacuum, essentially like Mars, only more of a vacuum. You know, that suit weighs like 300+ pounds, okay? And it's got multiple layers to protect from micrometeorites, to provide pressure to the crew, to provide oxygen, to provide thermal protection. You know, they wear a liquid cooling garment that has water tubes flowing through it. And it's got all these special joints and stuff that they can move. But astronauts really want something that is more flexible, is more mobile, especially when you're down on the surface. And, you know, we designed the International Space Station to accommodate the suit that we had to be able to do the spacewalks. But when you're actually down on the surface moving around, you want as much mobility as you can possibly get, as opposed to the suits that the Apollo astronauts wore.
Great. Let's go to another question here in the room from our students here in the front. Who's got a question? Hang on, we're going to bring you a mic.
Would it be theoretically possible to engineer photocells to be able to create life on Mars? It's not on.
Okay, I guess that was mine too. That's a very interesting idea, and I'd like to challenge you to perfect it. And then I'll let you know how we can get it to Mars and test it out, all right?
All right, let's go in the room. All right, we're going to take another question here in the room. Oh, come on. I know, it's like you guys were livelier before, so
don't be shy.
After working on the movie, what would be the hardest part of a trip to Mars?
That I have no skill set to survive, other than relating to other people and emoting for them. So I don't think I'm prepared. But I did learn a lot about chemistry and math and the sort of person that could survive there. So there's a model for me if I ever need to do that. But no, I would die.
So maybe we need to get Ray to lead a potato boot camp. Planning potatoes.
Yeah.
All right, so we've had questions coming in via social media, so let's get one of those right now.
So this question is from Tulsi Partridge, and it's for Bob Cabana as an astronaut, although I think it'd be interesting to hear from our in-situ resource utilization people. How plausible do you think the Martian is as a survival story?
I think it's absolutely very plausible. When Andy Weir wrote the book, he initially wrote it online by chapters and on a blog, and he got feedback from engineers and NASA scientists. In fact, Dr. Wheeler helped with potatoes. So, I mean, everything that he talks about is very plausible, and it could be. And that's, when we look to pick astronauts, we look for folks that have operational skills. They're obviously experts in their field, but, they do hands-on kind of stuff. One of my favorite stories, Dr. Don Pettit, and when I talk about persistence, Don got selected to be an astronaut on his 5th or 6th try, all right? When he was, I think he was like about 10 years old, his brother went to the junkyard and bought an automatic transmission and brought it home and gave it to Don to take apart for a birthday present to learn how an automatic transmission worked, And that's the kind of guy Don is. And he's a hands-on, he's really smart, but he also has that skill set, those tools that are needed to improvise. And that's what we look for, folks that can be in a challenging situation, that have proven themselves in similar situations through experience, so that when something does happen, that's out of the ordinary, they're cope with it, they're capable. So I thought it was an absolutely outstanding book. I couldn't put it down.
Hey, Annie, would you add to some of that? Because I think the work that you're working on is...
Yeah, so when I was reading the book, I was so excited because it talked about this ISRU module that got dropped down before the crew even arrived. And that's technology that NASA is working on now to develop. And that likely that's what will happen. So for me to turn the pages and read about something that I could relate to at my job to get humans to Mars, it was awesome. I mean, it was a page turner for me. Another thing I really liked that he did in the book was talk about the frustrations of communication. Because if you think about the ISS right now, that's real-time communication. But when we go to Mars, that's going to be a big delay in communication. You're going to have an autonomous crew that can really do a lot on their own. And so that's why being hands-on and understanding how to be innovative on your own is going to be so important for that crew. And one of the fun things, it's kind of a joke that I have in my head, but I got to get sent away to fake Mars for 120 days on a high seas mission, and we had to simulate living in a Martian environment, including the communication delay. We had a 40-minute communication delay with everything, including mission support, and I thought that was very well captured in the book as part of a challenge that the crew is going to have to deal with, because you're not going to be able to pick up the phone and say, how does this system work? Tell me now, it's failing right now. So I thought he did a great job in the book with all of that.
Okay, let's go to one of our questions on the DLN.
Hi, question. While in transit to Mars, what will the astronaut be doing?
So that's what would an astronaut be doing on the transit to Mars?
Are you looking at me? My longest mission was only 16 days. No, actually, this is, Scott Kelly is on the International Space Station now for a year, learning about what is required to keep a human system operating for that length of time. And there have been Russians that have flown in space for over a year, but it was a long time ago. And the unique thing about having Scott up there is that Scott has an identical twin brother, Mark, who is down on Earth, also participating along with Scott. So we're going to see how microgravity affects Scott for a year in space and be able to compare it to truth data on Earth. And that's pretty cool. But, the crew on the space station, they have some free time also. And they read, they listen to music. A number of astronauts have taken musical instruments along with them. Obviously, on a trip to Mars, storage space is going to be very, very critical. You're going to have to require to take a lot of stuff with you, and every extra little thing, it's going to have to serve a purpose. But, there will be crew health relaxation items that go along on the trip. You know, part of it's going to be just the normal maintenance of the vehicle that they're on as they go to Mars. You know, we spend a lot of time just keeping the International Space Station operating as well as doing science, and it's a full-time job. So the crew is going to be, they're going to be actively engaged every day on that journey. Exercise is going to be extremely important. The crew on the International Space Station has mandatory exercise 2 hours a day, and it's aerobic exercise, strength training, running on a treadmill. We found that running on the treadmill, you need that impact on the treadmill to the bones to help stem the calcium loss, very similar to osteoporosis. You need the weight training. We have a resisted exercise device that feels like lifting weights. You need that strength training also to stop the calcium loss. Plus, you know, after 6 to 8 months in weightlessness, you don't want to get to Mars and not be able to operate, even though the gravity is a third of what it is on Earth. You know, you're still going to have to be mobile and move around, so you need that physical fitness training. So they'll be exercising, they'll be maintaining the vehicle. Who knows, they may even have some science experiments that they take along. And they'll also have some free time to just interact and be normal.
All right, Zach, actually, I have a question for you. Who in the astronaut corps right now is the most likely to take disco?
To take what?
Disco.
To go?
To take disco as music.
Disco music.
Poor Mark Watney got stuck on Mars listening to disco, so I just wanted to know who the astronaut now is the person.
Yeah, that's interesting. I'll have to think about it.
You don't actually have to say, we don't want to embarrass them.
It wouldn't be me. That period of music can just go away as far as I'm concerned.
Mark thinks so too.
All right, let's go to another question here in the room. Who from our students has a question?
Hi, I know in the movie the character plants some plants on Mars, and you were talking about planting potatoes and growing things. How do you think it's possible that we could terraform Mars or begin in my lifetime?
Well, maybe Jim can weigh in on this too. Growing plants inside a controlled environment is one thing, and that has its challenges, but that's a lot easier if you have a controlled environment. You have the water and the light and the nutrients. Terraforming now on the outside Martian environment where it's very extreme in terms of temperature changes, the low atmospheric pressure, the high UV radiation, that's much more challenging. And so you'd probably, and maybe a logical sequence is maybe you try to do something to alter the Martian atmosphere somehow to make it more amicable and appealing to starting growing things. And then once, if that could take place, then maybe the environment would be, you know, supportive of trying to terraform. Jim, I don't know if you have any.
Yeah, so what will happen is scientists will resist the idea of terraforming. We want to know everything about the current state of the planet that we possibly can. We'd rather not modify it in any way. But I will tell you this, nature will modify it. The average temperature of Mars will continue to increase. And if it increases up to about 7 degrees, that's enough then to start melting the CO2 polar cap. Now underneath that CO2 polar cap is water ice. But when you melt the CO2 polar cap, that will heighten the pressure. And that will give you more of a greenhouse effect. That will then also increase the temperature of the planet. Then the water ice and the northern polar cap will melt, and a significant part of that lost ocean will come back. And Mars will look more like Earth at that era than it has in 3 billion years. So when we look at our planets, we're really looking at them in a snapshot in time. And they're all going through a whole series of evolutions. And that's what we want to understand as scientists.
So, Jim, I've got my reasons, but it's a question that hasn't been asked. I mean, we all want to, but why should we go to Mars?
Oh, as I said, we're explorers. This is a huge step for us. I see several with phones and computers in particular. I'm sure you will always back up your computers. We actually need a place to back up the human race. And I'm serious about this. You know, the dinosaurs didn't have a space program. We know an enormous amount about our environment, okay? and the environment that we're in the solar system. There are indeed near-Earth objects that are very large that are going to impact the Earth. It's not a matter of if, it's a matter of when. In the last 5 billion years, there's been 5 mass extinctions. If the human race is going to survive on this planet, we actually have to move. And that doesn't mean we're all going to go, but we have to be able to back up our human race. That's also part of our makeup. That's what makes us uniquely human. You can't stop it, even if you wanted to.
All right, let's go to one of our questions from the DLN.
My name is Paige Smith, and I go to Deer Creek Intermediate in Wisconsin. My question is, how long has Mars been studied?
Good question. So this year, it was August of this year, marked our 50th anniversary of studying Mars. And our first mission to Mars flew by it. And when that happened, the scientists you'd think would be really joyful, and in reality they weren't, because the area that we saw mostly was cratered, and we thought Mars looked more like the moon. And it actually set back Mars exploration for many years after that. After our flybys, we decided we needed orbiters. And so in 1969, 1970, we started with our orbiters, and then we began to realize how complex Mars really is. It has clouds. It has snow. It snows on Mars. The seasons are there. The vistas are unbelievable. It's got huge canyons that if the Valles Marineris would be in the United States, it would link the Atlantic and the Pacific together. It's got shield volcanoes bigger than the state of Missouri. I mean, it's an unbelievably beautiful planet in many different ways, and really changed our opinion of it. And now, the more we know about the resources that are there, the more we recognize that this terrestrial planet is most like Earth and the one that we can go to. And I believe there's a person or a number of people that are alive today that will be the first people on Mars.
Maybe somebody in this room?
I hope so. I'd like to meet you.
All right, let's take a question from in the room. Do you still have a question? Somebody raised their hand earlier. All right, let's go right here.
Why is the government interest in space exploration seems to be decreasing lately? In about 10 years during the Cold War, we went from low Earth orbit with the Mercury program to the moon, the Apollo missions. And since then, we only send humans to low Earth orbit again. Do you feel we need competition and rivalry for science to develop?
First off, it was absolutely amazing what we did during the Apollo program. When you consider that Alan Shepard flew the first flight, first American human to fly in space, in May of 1961, and he did a parabolic arc up into space, floated for about 15 minutes, and came down on the Atlantic Ocean. And a little over 8 years later, we were walking on the moon. You also have to realize that at that time we had 4.5% of the federal budget. We have less than half of 1% now. So we learned a lot. Given the resources, I think that we're doing an outstanding job. So we transitioned from the Apollo program. We did Skylab, our first space station. We did the Apollo-Soyuz test project with the Russians. And we transitioned to Shuttle. And Shuttle would have flown sooner, but it got delayed. But in April 12, 1981, we flew the first shuttle mission. And for 30 years, we had the most awesome shuttle program. It was fantastic what we accomplished. All the science missions, the Hubble Space Telescope, building the International Space Station. And now, with the International Space Station, we know how to get back and forth to low Earth orbit. It's time to transition low Earth orbit operations over to the commercial sector so NASA can focus on the really hard job of exploring beyond our home planet. So I think the course that we've laid out is a very good one, and we're going to make it happen.
Great. All right. Do we have a quick question from social media?
Okay. This question comes from Kelly Jaster on Twitter. How are we protecting Mars' environment as we explore the surface? Welcome to speak to Greene.
So when we launch spacecraft and we study what, we know what their requirements are, we also study how that spacecraft might affect the environment they're going to. And we call that planetary protection. So we actually have in NASA a planetary protection officer. We interact with Cassie Connolly, planetary protection officer, and she helps us through making the decisions on what we need to do to be able to protect the environment we're going to. Give you an example. We have a spacecraft right now orbiting Saturn. It's called Cassini. Saturn has fabulous moons, one of which, Titan, has an atmosphere that's like ours in the sense that it's mostly nitrogen. It's a wonderful world. It's got liquid on its surface, and we would not want to contaminate it by having Cassini crash on Titan. And so we're going to ditch Cassini into Saturn. And we're going to start that process about September of next year.